So we are going to look today, let me unfreeze this. We're going to look today on perimeter and area, the section on perimeter and area. And the first thing that they want us to examine are polygons. So what is a polygon? Well, first of all, a polygon is just a closed figure. So we have that closed shape they see. That's just a standard polygon. Now, it says that in geometry, a figure that lies in a plane is called a plane figure. So anytime we're working with a coordinate plane and we have a shape on that coordinate plane, we're dealing with a plane figure, or on another plane other than the XY axis. It says, recall that a polygon is a closed plane figure formed by 3 or more line segments called sides. So they have examples of sides. We now know how to label those sides. Each of these sides is not a line, it is a segment that ends. So you want to make sure that you annotate that correctly. So if it's side BC, you want to put the segment bar above it if you are noting that. Remember that the only time that we don't put the segment bar or the ray on top of it or the line is when we're solving for something and we're saying, for example, BC equals a certain measurement. That's when we don't have to have that on top. It says each side intersects exactly 2 sides, one at each vertex. So that point of intersection between 2 sides, between point BC and DC, that's called a vertex. We often label vertexes for our angles with an arc, just like that. So we'll talk about naming angles pretty soon, but that's a vertex, this is a vertex, this is a vertex, this is a vertex, etc. And we just call them by that point, vertex C or vertex D. And it says each side intersects exactly 2 sides, one at each vertex, so that no 2 sides with a common vertex are collinear. And you can see that. BC and CD, they have a common vertex, vertex C, and they're not on the same line, obviously. They intersect at that vertex C. Now, it's how do we name polygons? Well, just name them by the vertices in consecutive order. So we start here, and we typically go clockwise. Okay, that's one thing your book doesn't say, but when naming, we want to name clockwise. And you can see that they did that, A, B, C, D, E. When we start looking at rotations and transformations on the coordinate plane, you'll know that that order does matter. It does affect those sorts of transformations. Do you have any questions on what a polygon is, what a side is, what a vertex is, and how to name these polygons? No questions? All right. So here we're looking at concave versus convex polygons. Remember, your polygon is an enclosed shape with 3 or more sides. A triangle is a special type of polygon. A pentagon is a special type of polygon. And usually when we name these polygons, we name them based on their sides. And you can see with the prefix, it kind of gives us a hint. So tri meaning 3, so that's why we call it a triangle. And it has 3 angles. Quad meaning 4, so quadrilateral. Penta meaning 5. Hexa meaning 6. Hepta meaning 7. Octa meaning 8, nonagon 9, decagon 10, dodecagon 12. Now, if you don't want to name them by those types of polygon names, those special names, you can always call it a 12-gon or a 13-gon, but we save the n-gon thing for anything typically above 12. So these are common types of polygons. You do want to memorize these things. You do want to know that you have a triangle, obviously. 4 sides is quadrilateral. For some reason, a lot of students mess that up. They think quad means 5, but quad is 4. So quadrilateral, if I say, here's a quadrilateral, you should automatically think I'm dealing with a 4-sided figure. Pentagon meaning 5. Hexagon, I don't know. I think of it a weird way. I'll tell you how I think of hexagon. So this is kind of dark, but like, you know how you can put a hex on someone, like a witch? I don't know. But have you ever heard of that, hex, putting a hex on someone? Well, you know how like 666 is like the devil number? Well, I think hex, I think 666, and I'm like, oh yeah, 6 sides. I know. Well, we don't practice witchcraft or anything in here. I'm just telling you an easy way to remember. Okay. Now, as far as determining whether or not your polygon is convex or concave, there are a couple ways to think about it. Concave polygons cave in. So like this caves inward, so it's concave. Convex polygons don't cave in. Another way you can think of it is if you take a side and you were to extend that side, just draw a straight line. If at any time, like they're extending this side here, this little side, if at any time it goes through your figure, then it's concave. If it doesn't go through if you extend all your sides, like they did here in red, they just drew lines, and it doesn't go through your figure at all, then it's convex. So on the test, when I ask you, if I give you 2 or 3 figures and I say, which figures are concave and which figures are convex, you'll know either by saying, well, the concave ones cave inward, or if I draw a line, if I extend all those sides and that line extension goes through the figure, then it's concave. Questions? Okay. Anyone? So what's the first one? Concave, it caves in, and like I said, you can always extend this side. And if I extend that side, it goes through the figure, so I know that's concave. As is this one, concave. Extend that side, goes through the figure. That's what? A B. Convex and convex. Okay. Questions? No? All right. Area. So they want you to calculate area in this chapter, meaning they want you to memorize even more formulas. So let's think about the formulas we've had to memorize so far. We've had to memorize our midpoint formula and our distance formula. And I'll write those down. And to that, we're going to add these 3. Now, you should have encountered these in middle school. Right triangles. You can determine the area with a right triangle or an obtuse triangle or an acute triangle with 1/2 base times height. And the reason is you can draw what's known as an altitude. An altitude is a line that forms a right angle. And we'll talk more about that throughout the year. But sometimes that altitude will be on the inside, sometimes it will be on the outside, or sometimes, most commonly with a right triangle, it'll be on the side. But as long as it has an altitude, you can use the formula 1/2 base times height. The only triangle that we cannot use 1/2 base times height is called equilateral, and we'll talk more about that later. But for now, in this chapter, all the triangles that you're going to be dealing with, you can draw some sort of altitude, meaning a line that forms a right angle with the base, and use 1/2 base times height. Squares are just, all sides in a square are the same. If I asked you to classify a square as a specific type of polygon, what would you say? It's a quadrilateral. So if you classified it by its sides, it's a quadrilateral. And by its special properties, it's a square. So a square is a special type of quadrilateral that has right angles and has congruent sides. So area is just side squared, or side times side. So we should remember that from middle school. Perimeter, you're just adding up all the sides on all these. So for the triangle, you're adding up all the sides. For the square, you're adding up all the sides. And most commonly with a rectangle and square, they kind of note our perimeter a little differently, but it's saying the same thing. Since all the sides are the same, you could add them all up, or you could just take 4 times the side. Same can be said about the perimeter of a rectangle, or at least similar. You have a length and a width. The lengths are the same. Notice with the hash marks. I have 2 and 2, so that means they're the same measurement. We talked about that yesterday. With 1 hash mark, with my width here, and I have another 1 hash mark, single hash mark, that means that the widths are the same measurement. So see how they noted that on the picture. So because I have widths that are the same and lengths that are the same, I can think of adding up all the sides as 2L plus 2W. And of course that area is length times width. Do you have any questions on those 3 formulas? Triangle, perimeter and area, square, perimeter and area, and rectangle, perimeter and area. Midpoint yesterday we talked about. That's just finding the average, midpoint, middle, average. That's just taking your x coordinates, x1 and x2, adding them and dividing it by 2. And your y coordinates, y1 and y2, adding it and dividing by 2. Distance formula was the hard one. It always has a square root in it. This is the one that you'll probably have to memorize at this level unless you understand it intuitively. So it's the square root of x minus x. We'll just say x2 minus x1 squared. So the x's, subtracting, plus the y's, y2 minus y1 squared. And we talked about that. That can be used whenever we have a diagonal distance. Let's say A and B, and let's give those different coordinates. Say that's x1 comma y1 and x2 comma y2. So to find the distance of that diagonal segment, I just subtract the x's up here and then take it squared. And then I'll write that number down. And then you're going to subtract the y's. Take that squared, write that number down, then add them together and square root it. It's a process. It just takes some getting used to, but after you've done it for a while, you should be fine with it. Remember, with horizontal and vertical segments, like I've said before, you just have to take the difference, the absolute value of the difference to find those distances. Do you have questions on any of that? Well, now we get to apply it. It says find the perimeter of triangle ABC. Notice that they labeled a triangle with the triangle sign. And then, of course, they labeled it A, B, C. So they labeled it with those vertices. Now in this case they went counterclockwise. That's okay. The counterclockwise clockwise thing is really going to matter when we look at rotations and stuff. So just name it with the vertices. But I would say for reference, just try to put things in clockwise order. But it doesn't really matter at this point. So they have those vertices, they have this triangle. Find the perimeter. So to find the perimeter of a triangle, what do I do? What's the process? Add all the sides, which means I have to find all the side lengths. So I'm going to find this side length. Do I have to use distance formula here? No. So how do I find the distance for CB? what do I do? Thoughts? So you know I don't have to use the distance formula. How do I find the distance of a horizontal segment or line? Find the difference, right? So again, think about what makes sense. It doesn't make sense to take -3 minus -3 because that'll just cancel out. What's different here? These two. So I'm going to find that difference, the absolute value of that difference. So -2 minus 3 equals -5 equals 5 units. Again, I did not use the special annotation because I have equal signs. So someone said, can't you just count the boxes on here? You can just count the boxes. What I did up here is I just did the algebraic way. So let's say on a test, do you have to show your work for that? Not really for that part. I understand that if you want to count the boxes, you counted the boxes. That's okay. Now, you can't, unfortunately, do that for every side. We can do it for AC. Or if you want to do it the algebraic way, think again, what makes sense? It doesn't make sense to take -2 minus -2. So what's different here? The y's are different, 3 and -3. So I'm going to subtract that. 3 minus -3. And that's going to be 6 units. And you can count and get 6 units. So I have 5 units and I have 6 units. And now I have to find the length of this diagonal. Can I use counting or just subtraction? No. This is when we have to use that distance formula. So the length of AB, square root, I'm going to take the x's and I'm going to find the difference. So I have a -2 and I have a 3. -2 minus 3. Then I'm going to square it. And then to that I'm going to add the difference between the y's. So I have a 3 and a -3. So 3 minus -3. And then I'm going to square that. Using a couple parentheses here to keep everything, all my signs good. So now it's just a matter of simplification at this step. So -2 minus 3 is -5. So I have -5 squared plus -3 minus -3, or 3 minus -3, add the opposite. So I get plus 6 squared. You with me so far? And then I'm looking at this, 25 plus 36, which is what? 61. That should be right. I'm just following along example 2. So the x's, subtract them. The y's, subtract them. Does this all make sense? Yes. And then, of course, what do? I can take this in my calculator and then add it to those other side lengths and then say what my perimeter is. Yes? So go ahead and do that. Round to the nearest 10. They got this to be approximately 7.81. And then when you add 7.81 plus 5 plus 6, what do you get? Say it louder, what? 18.81. So our perimeter is not equal to, it's approximate because we rounded, approximately 18.81 units, not units squared because it's perimeter. Yes?
So, if you did the method where you're just counting the boxes and you got the distance, could you just use the Pythagorean theorem then?
That's a great question, and yes, you could. Yep. And that's essentially what you're doing. This is essentially what we're doing.
Yeah.
Because remember, the distance formula is a deviation of the Pythagorean theorem.
Mm-hmm.
You guys are so smart. Okay. So, you should be able to notice at this point that if I'm given 3 points, I probably have a triangle. And it's a good idea to have graph paper with these types of problems because on the next problem that I'm going to have you work on your own, they don't provide the graph for you. And so if you wanted to count the sides that you could count, in order to get the correct answer, you'd have to have a grid that was spaced out correctly. Just FYI. Now, they gave us the triangle here. I noticed on the last one I had a right triangle. This is an ugly right triangle, but I had a right triangle where the altitude, or that line that makes this 90 degree, that segment, I keep saying line, it's a segment, that segment that makes a 90 degree angle with the base was on one of the sides, yes? Now, where do you think that altitude is going to be for this triangle? The 90 degree angle. Is it going to be on the inside, the outside, or on it? On the inside, right. So this is already like chapter 6 stuff, kind of. So all you're going to do is you're going to take the easiest one. You can draw altitudes all along the inside of this. But I think the easiest one's the top one. Why? Because if I draw a segment from D to this point here, this point is a nice easy number that I can just count, right? This is 1. 1 unit on the x-axis and -3, that point. So that's what I mean by a nice point. If you draw altitudes here, that could work too, I suppose. Here it's not very nice because this isn't even, right? So do you see what I mean about when you draw the altitude, just pick the one with a nice point. And the ones that I'm going to give you and you're going to see on your homework, you should just be able to use the top one, I'm pretty sure. So let's go back. And I didn't draw those altitudes very well. They should meet in the middle. But I'm going to draw that again, just the top one, because that's the only one I need to use. From top to bottom, I'm going to draw that altitude. Not drawing very straight today. And then I'm going to draw that right angle right there. That's the altitude. I'm going to label that point to kind of help me out. I'm going to call that point M. And I'm going to figure out what that point is. So it has 1 for the x, and the y is -3. Now it wants me to find the area, so I can use 1/2 base times height. I can find my base just by counting the boxes. So what's the length of my base? Length of this base. One, 2, 3, 4, 5, 6, 7, 8. Right? 8 units. So FE is 8 units. You guys know which one's the base and the height, right? Okay. And then how tall is my height? DM. Huh? 6 units? That's what we got. 6 units. 1, 2, 3, 4, 5, 6 units. 6 units. And so now I just plug it in the formula, right? 1/2 times 6 times 8, which is just 3 times 8, which is 24 units squared. One thing I want to caution you of, this is kind of a thing for algebra, geometry, etc. If you're going to give me a grid that you're going to do yourself, make sure that you label it correctly. So arrowheads at the end, because we're dealing with a plane that extends forever in both directions. Also, let me know your units. So if you're going by ones, I can see here I'm going by ones. And then label your X and your Y. That's just a notation thing. Of course, for me, since I couldn't just count, I guess you could, I used just the definition of distance to find the distance for NM and LM. And then the area formula, 24, is what I got. Units squared, so you want to put your correct units. Okay, the last one's a word problem, but it's essentially the same thing. It's just talking about, I'll show it to you. We'll just talk about it. You don't have to write it down, unless you want to. Do you want me to go back? Are we good? Okay, this is just a word problem. It says you are building a shed in your backyard. The diagram shows the 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Find the area of the floor of the shed. So it's essentially the same type of problem. You're just gonna, you can count here, this is nice. You can count those units, and then multiply them together. Yes? And then don't forget units. Well, it's not gonna be units squared, it's gonna be feet squared. So we're done with notes today.